Hi everyone, here I am going to discuss about haloalkanes and haloarenes. So let's start. Haloalkanes and haloarenes. Halo, that means halo means the halogen groups. Okay, so the halogen groups. The halogen groups are represented by capital X. Okay, so we have fluorine, chlorine, bromine, iodine, group 17. Okay, so the halo means the halogen groups are called your halo. Okay, let's understand in this way. Okay, now there is another word here, alkane. Alkane means we have learned the formula is CnH2n plus 2, or we can say or CH4. We can take the example C2H6. Now we are able to understand haloarenes a little bit. Halo means there will be presence of halogen groups. Alkane means there will be presence of carbons and hydrogen. Now, how to prepare your haloalkanes? And also let us know haloarenes. Now it is not alkane, it is arenes. Halo means okay, halogen groups. When we talk about arenes, we are talking about aromatic ring. Okay, so haloarenes. Okay, so arenes means, let us say arenes. So this is arene. Okay, so like this is alkane, so in this way the aromatic rings are called arenes. Now, how to prepare haloalkanes? Right, so we can prepare haloalkanes by replacement of, we are going to replace one of the atom of hydrogen in hydrocarbon. Let us take a hydrocarbon here, CH4 I have taken here. Okay, I have taken hydrocarbon. It can be aliphatic or it can be aromatic. I have started with the aliphatic, that means chain. Okay, not ring. So I have taken here, then just replace. We have to replace the one of the hydrogen. How many hydrogens are here? 4 hydrogens. We are going to replace hydrogen atoms. It can be one, you can replace one hydrogen atom, you can replace 2 hydrogen atoms. So the replacement of hydrogen atoms in a hydrocarbon, so this is your hydrocarbons made up of carbon and hydrogen. It can be aliphatic or it can be aromatic, by halogen atoms. Okay, let us remove this hydrogen, one of the hydrogen, and let us replace it by chlorine. Let us add chlorine. So now see CH. Now it was initially it was 4, now it will be 3, then Cl. Okay, here see we have taken CH4, and instead of Cl we can replace by any halogen group. So I have taken here as X, that means X represent any halogen group. So we have 4 hydrogen here. Replace one of the hydrogen and replace it by halogen group. Okay, so we have represented in this way. Now let us take another, that is C2H6, which is called ethane. So same way we have 6 carbon, we will replace one of it by Cl group, one of the hydrogen we will remove it and we will replace it by the halogen group, and we came to here C2H5 X. Okay, so what differ here is that this group CH3, C2H5, this alkyl groups goes on changes, right? So we can represent this by R in order to term in the general form R H. Okay, this is your alkane, this is your alkane. Then it has changed into R, one of the hydrogen is replaced by X, so this is called your haloalkanes. Okay, so since this is aliphatic, so it is called haloalkanes. Okay, so this is the general formula. Now when we talk about arenes, see, we have benzene ring, we have, let us replace it one of the hydrogen. Okay, let us replace one of the hydrogen by any X group. Okay, let's write X. So there is presence of hydrogen. Remember that there is presence of hydrogen in each carbon. So we will remove it, any one of it, and we will replace it by X. So this is called this is called your haloarenes. Okay, this is called your haloarenes, or we can also call as alkyl halide. So alkyl halide is your common name, and alkyl halide is your common name, and haloalkanes is your IUPAC name. Okay, so this is what, in according to IUPAC name, this is haloarenes, and according to the common name it will be aryl. Okay, we will use the term aryl halide, HALIDE, halide. Okay, so this aryl halides in terms of common name. and in terms of IUPAC name, it is called haloarenes. Okay, this is haloarenes. Same way here also, and this is your, in terms of common name, this is alkyl halides. Okay, alkyl halides, or in terms of this your common name, in terms of IUPAC name, it is called haloalkanes. This according to the IUPAC. Okay, IPAC naming. Okay, so let us go to the next one. So haloalkanes, once again haloalkanes. So let us know the differences between haloalkanes and haloarenes. When we talk about haloalkanes, see, does this Cl or this X is connected to this carbon. Okay, let us focus on this carbon. This Cl is connected to this carbon. Now this carbon is all a single bonded carbon. So when it is single bonded carbons, we know that the carbon is sp3 hybridized. Okay, so this carbon is sp3, this carbon directly connected carbon is sp3. Okay, so this is also directly connected carbon is sp3 because all are single bonded, there are no double bond in this carbon. So I have shown here in order to understand well. So CH3, so it is in the form of tetrahedral, so it is sp3. So carbon, we have to concern about, or we have to focus on the carbon that is directly connected to the Cl. Okay, so in the let's see what's the difference here. This carbon, see, double bonded, this carbon bond Cl connected carbon is double bonded, that means carbon with double bonded is sp2 hybridized. So the difference is that here one is attached to the double bonded carbon and the other is connected to the single bonded carbon, which is sp3 hybridized, and this is sp2 hybridized. Okay, this is the difference between haloalkanes and haloarenes. Now let us classify carbon halogen bonds in terms of hybridization. So let us say alkyl halide. When I say alkyl halide, this is what, let us say this is your alkyl halide. Let us take any carbon. Okay, CH3. Okay, halide, let us take by X. Okay, this is your alkyl group and this is your halide group. So this carbon is called your methyl. This carbon 1 CH3 X is called your methyl halide. Okay, this is your methyl halide. Now let us go, or let us change one of the carbon with one of the hydrogen with R. Okay, one of the hydrogen with R. Now this change into primary halide. Why? Because see, we have to focus on this carbon halogen bond. Okay, and let us see this carbon is connected to how many other carbon. This carbon is connected to one. R means carbon, so this carbon is connected to one carbon, so this is called primary. Now I can change it into secondary again by changing one other hydrogen by R. So now it is what, C, let us always make this one. Okay, C bond X. So we have to see this carbon is connected to how many carbon. So carbon, carbon, R means carbon, alkyl, carbon, carbon. It is connected to two carbon directly. That means carbon bond X carbon is connected to two carbon. So this is secondary, and tertiary will be, you have to replace all your hydrogen. So now it become as tertiary. Okay, so now this is your tertiary, this is your tertiary, this X. Okay, this carbon connected to X is, this carbon is connected to how many carbon? Now it is 3, so it is tertiary halide. Okay, this is your tertiary halide, this is your secondary halide, this is your primary halide, and this is methyl halide. Okay, so all these carbons are single bonded, so it is sp3 hybridized. This is also sp3 hybridized, this is also sp3 hybridized. So sp3 hybridized we will classify, that is alkyl halide. Again, alkyl halide can be classified into primary halide, secondary halide, and the third one is tertiary halide. Okay. Next, we are going to talk about allylic halide. In the allylic halide, we have to remember that there is 3 carbons. Allylic means 3 carbons with double bond, one double bond. So double bond, single bond, and this carbon is connected to X. Now this carbon is what type of hybridization? It is sp3. Okay, because carbon is single bonded. That okay, it is in the form of tetrahedral geometry here. So sp3. Let us go to another allylic. This is also in the form of allylic. See, CH, okay, then CH2, 1 2 3 4 CH. And see, this from the form of double bonded carbon, single bonded. Okay, so this also in the form of, or this also in the form of allylic form. This is in the form of allylic halide. Okay, so how many carbons are here? 1 2 3 carbon. The third carbon is connected to X. So this is your allylic. Okay, so this is also in the form of allylic. Next we'll go to the benzylic halogen. When we talk about benzylic, remember about benzene. Okay, so this is your benzene, but we are going to talk about benzyl. When we talk about benzyl, CH2. Okay, so this is your benzyl group, benzyl. Okay, benzylic. Now this is your halogen, so benzylic halogen. Okay, so benzylic halogen. So when we say halogen, we will put halogen here. Okay, so this is your benzylic halogen and this is your allylic. Both are same. See, if we talked about whether this compound is allylic carbon present or not, yes, we will say allylic carbon is present because 1 2 3 carbon with double bond. Okay, and the terminal double bond is present. Now let us talk about the combined. All these are what? All these carbons, all these halide are sp3. This is also sp3. So we can classify carbon halogen bond in terms of hybridization. So let us see here. In terms of sp3, alkyl halide. All our alkyl halides are sp3 hybridized, sp3, sp3, sp3. So alkyl halide we can classify into methyl halide, then primary halide, secondary halide, tertiary halide, right? So and another we have also, that is allylic halide. This is also sp3 hybridized. Now let us go to the compound containing carbon halogen bond, but in this case it will be, the carbon will be sp2 hybridized. That means the carbon connected to X halogen, that carbon will be sp2. This is vinylic. Vinylic means 2 carbon, allylic means 3 carbon. So vinylic 2 carbon, double bonded 2 carbons, so connected to X directly. That means this halogen is connected to carbon which is double bonded, that is sp2 hybridized. This also, see, this in the form of ring, but still it is in the form of vinylic. Carbon carbon double bonded, and it is the halogen connected carbon is double bonded. So this is called your vinylic. So vinylic and allylic are little bit different. What are the differences? One is 3 carbon content with double bond and the other is 2 carbon content with double bond. The halogen that is attached in the allylic halide is sp3 hybridized, that is single bond, and in this case vinylic halide it is double bonded. The halogen connected carbon is double bonded, that is sp2 hybridized. Okay.